Hello and welcome to our video from oorail. Today we're doing the first how-to video on how to build your own digital DC power control system. So basically what we're going to do is show you how to create a computer-controlled train control system. And it's very easy, and it's actually not that expensive either. I believe it costs, this initial part of the setup cost me less than $20. So definitely it's something that's affordable, and it gets you kind of into some electronics as well. So if you haven't seen the demo of our open source computer control system, I'll stick a link up here and you can check out that video. So today what we're going to do is going to walk you through a couple of options. Obviously there's different ways to do this, and so you can pick and choose how you want to do it. You can also integrate part of the system in with DCC. Even though the track control module would not work with DCC chipped locos, and I definitely recommend you don't try that. It will work fine with DCC ready and standard DC locos, because it uses 12 volt DC on the track, where DCC uses a special kind of AC like signal. Alright, so today what we're going to do is show you how to go about building the power supply. Before I do though, what I want to do is show you something called DIN. And so this is what's called a DIN rail, and it's used in sort of industrial computing and industrial applications. And one of the cool things with this is that you basically just mount it either to the side of your layout, maybe a post or wall or something beside the layout, and it's very simple to mount. You just simply put wall screws or wood screws in through the holes to secure it, and you just make sure that it's level. Now the reason this is kind of cool, this is actually a terminal block. So if you look here, and you put a wire in one end and you screw it, and wire in bottom and you screw it, and these are rated up to like something like 200 amps or something, so you're never gonna blow through one of these with your model railway. But the reason I'm showing you this is that they have this little clip system. So you see there's like a notch there and a notch there, and what it does is actually goes into the rail. So you kind of clip angle it like that, and it should hopefully clip in like so. And so what you can do is you can configure these any way you want. It's highly modular, and there's tons and tons and tons of industrial supply DIN modules. You can get things for holding Raspberry Pis, for holding Arduinos. You can get it for power supplies. You can get displays. You can get all sorts of things, and they all mount to these DIN rails. Now the DIN rails aren't very expensive. You can get a pack of about 8 or 10 of them for about 10 bucks. And what's really cool is these terminal blocks come in about a pack of 100. You can get less, and they come in different colors. But you can see here, you can wire things up any way you want. And so this box of 100 pieces, I think, cost me less than $30. So like I said, it's a very, very slick sort of solution. So what you do is you can, when you get to the end piece, they have end pieces that clip on, that close off the electric connections as well. So you can configure these any way you want. And you can buy power supplies like this that also clip onto it. So you can have it set up like this. So basically you pull this tab at the bottom, line it up, push the tab in, and then your power supply. It's not going anywhere, and obviously you'd have this mounted. So you can have bus wires maybe coming from a bottom one that go up into your power supply, and then out into your layout, and then you can mark them or whatever. You can also buy blocks of these, and that come numbered. And so if you're trying to do points or something like that, you can always wire them up, and then you can, beside your layout, have that information and stuff on it. To remove stuff, it's really simple. You just pull the tab back, and it comes off really easily like so. So yeah, it's a really cool solution, and I'll do another video on DIN in more detail, but I thought I'd show you guys that. So all we're really going to need for today is we're going to show you how to put together the power supply. I'll do another video later this afternoon on how to build out the board and stuff like that, and connect the board to the power supply. But I thought I'd start off with the power supplies. So I've got a collection of power supplies here. I've got some Meanwell power supplies. Now Meanwell is a Chinese brand, and it's kind of a upmarket Chinese brand. They're used a lot in 3D printers. There are dozens and dozens of Meanwell power supplies. What you need to look for is that they output 12 volts, and you need to look for the ampage. So this one's 1.3 amps. Now most modern locomotives will pull a couple of hundred milliamps. So you could, in theory, drive 2 tracks with modern locos with the 1.3 amp. Might be a bit on the low side. You probably want to like aim for 2, especially if you have older locomotives. If you have older Hornby or triangle locos, you can almost guarantee they're going to pull at least an amp. They might pull 2 amps. You might want a more beefier power supply. This one here is a 12 volt and it's 2.1 amps. Now you can buy these power supplies on Amazon. I think they're less than $10. Some of the more beefier ones might run you up like 15 or 20, but they're usually not that expensive. Wiring them up is really easy. They have a AC side, which is here. I'll try to, if I move this around on the other camera, you can probably see it. So you have the AC live and the AC neutral, and this kind of arrow pointing down with lines on it is the ground, and then you have the plus and minus voltage. You also have this adjustable thing here that you can adjust the potentiometer. You can adjust it up or down for the output voltage. What you really want to do is max it out, and if you use a multimeter on the V plus, V minus to check the output, it's going to probably register more than 12 volts. Don't worry about that because it'll register more than 12 volts. It'll probably register like 15, 16 because there's no load on it. Once you add a load to it, it'll drop back down below 12. So that shouldn't be a problem. Now I'm showing, I also have these power supplies. Now these power supplies are also Meanwell. This one's 12 volt, 1.67 amps. You'll also notice down here that their input voltage range is 100 to 240 volts AC, so these will work in Europe, in the UK, as well as here in the States. You just have to wire them up, and likewise these just have an input wires, so you input ground, neutral, and live. You do not need to do any soldering whatsoever. I'll show you what you can do, but basically you just undo these screws, put the wires in, screw it back up, and you're good to go. This one has plus and minus voltage that goes to your motor board. So if you're using like an L298N, these would go to the VN and ground on that board. There's also a light that tells you whether DC is okay, and I think there's a sensor for it as well as for a light here, and you can also adjust this too. Like I said, you want to max it out so it's the full 12 volts. One thing I wanted to show you, oh, I should probably tell you the model number. This one, the model number is MDR 2012. 1.67 amps is probably the lowest I would recommend. All right, so one thing I want to show you is the one that we're actually using on the layout here. This is, doesn't have a part number at. Oh, here it is. It is MDR 6012. And again, this is 100 to 240 volt input. It's a 1.8 amp input on it. And basically this power supply will output 12 volts DC at up to 5 amps. So this is powerful enough to drive 2 motor controllers. So you have V plus for one and V minus for the other, V plus for one and V minus for the other. And I believe there's also a switch here for DC OK. I think it's a relay. It'll relay on off if it's okay or not. The DC OK light here will also tell you if it's running, and then this is the adjustment. Like again, you want to max it out. If you're not quite sure, you can always put a multimeter across V plus, V minus, and check the output. And again, if you've got no load on it, it's going to register a little bit higher than 12 volts. It should register maybe 14, 15, 16 volts. Don't worry about that. If it's registering like 35 or something, obviously there's something wrong, but you want to make sure that it's only registering 12 volts. Now you shouldn't have to worry about it. Just keep in mind, if you go shopping around on Amazon and places like that, they do sell 24 volt ones. So you want to make sure these last 2 digits say 12 and check that the thing is 12 volts, or else you might blow some stuff up. All right, so let's go show you how to wire this stuff up. Oh, before I do that, so the electronic components that we use, like the ESP32, Arduino, stuff like that, they all run off 5 volt DC. And so what you can do is, this is a MDR 25, so that last digit has 5 on it, and that's because it's a 5 volt output. So this will do 5 volt DC at 3 amps, and 3 amps is crazy high. It'll power a couple of dozen devices with that because they pull so little current. So what I use this for is basically a kind of power bus for the electronics. So I'll bring in the AC in here, and then I run the V minus, V plus into a terminal block, and then I run the terminal blocks over to various different components. And so this one power supply can power all of those ESP32 modules very, very easily. You just run some extra wires and some extra terminal blocks, and it's definitely really cost effective. So that's something to keep in mind with the rail system. And of course you can buy these in 5-volt outputs as well. And remember, the ESP32, while it uses a 3.3 volt input, it has a kind of built-in regulator, so it can convert the 5-volt down to 3.3 volts. So it's very easy to go ahead and use. So what I'm going to do is show you real quick how to set this thing up. So first of all, what you're going to need is you're going to need an AC mains power lead. So this is an American one because I live here in the States. So you'll have a plug that's appropriate for your country, and then on the other end, you're going to have 3 stripped wires. So you should have a green one, which is the ground, a white one that's neutral, and then black or red, which is the live. And the cool thing with this is this is a power supply, and I'll explain this in a minute, but these basically have a ground, a neutral, and a live. So all you have to do is strip the wire and stick them in the appropriate holes, and then screw them in, and you're done. So before I continue, I want to show you a quick trick that you can do. So if you're unable to find one of those cables I just showed you, this is a standard computer cable, so it's got that connector on one side, and it's got this standard computer connector on the other. You can actually chop this part of the connector off and get the same type of wire. So if you have a whole bunch of these laying around, like a lot of people do, you can just chop it off. You do want to make sure you check the rating. So for example, the rating should be on the bottom of the plug. This one is 125 volts at 10 amps. When you cut it off, this is from the one I chopped off for the project that we were doing, but you can see there it's got the green, white, and black wire inside it. And so you discard this. Make sure you throw this away. You don't want your kid or something plugging this into the back or something, or plugging in something else. So and which, by the way, I did when I was little. So definitely make sure you throw this away. The green is ground, and it's going to go into the first connector. The white is the neutral, it's going to go into the second connector, and the black is the live, and it's going to go into the last connector. So what you do is you take your screwdriver, you put it in here, and you just basically turn it counterclockwise a couple of rotations. You don't want to remove the screw, that's for sure. You just want to do a couple of rotations like so, just enough to get the wiring in there. And if you look in here now, you can see that the plates have separated a little bit, so you can put the wires in. So the first thing to do is to strip all the wires. So I'm using this automatic wire stripper. You can adjust it how you want. I want it to, it's in inches. It has millimeters on the other side. Of course it does. So what I'm going to do is just simply push it down like so, and it strips it off like that. I think I'm going to need a little more off of it, so I'm going with just over half an inch like so. And all you do is just twist it like that. Next one is the white wire. You just push it up, and push it up against it like so. Push down, pull, and then just twist. There's absolutely no soldering involved in this project unless you want to. So you can definitely, if you know good at soldering, get away with that. So what you do next is you start with the ground wire. You make sure green goes with the ground symbol. Simply put it in there like so, as far as it'll go. Take your screwdriver, screw it down, and then just do a quick tug test to make sure that it's not going to come out. Likewise with the neutral, you line it up white, neutral, put it into, you will want to make sure that you have these spun around properly. You can always tin these if you do have a soldering iron, but I'm going to try to do this without one. Like so. You just hold it in place with one hand. My thumb, you can see there, it's holding that in place. And you simply screw it down like so. And it's good. And then finally, you line this one up. Make sure it's in, hold it in place, and screw it down. like so. And so here in a minute, what we'll do is, actually I can probably do it now. Just put a power plug down there. So what we'll do, hopefully this isn't my last video, we'll go and plug this in. So I'm going to take this end and plug it in, and we should see the power supply light up. Like so, and it has. That click is power supply coming on, and you can see there it's got DC OK. So what we'll do next is we'll take the multimeter and measure the output and adjust it, but typically you can get away with just tuning it all the way as far as it'll go, and it should be good to go. So what you do to wire up your track, you use the plus and the minus here, same deal. Unscrew it obviously not with it powered up, plug the wires in to your layout and go on from there. So in the next video, what we'll do is we'll show you how to wire together the breadboard with the modules and so on, and how to wire that into this power supply and get it controlling the track and so on. Alright, so that's it for this video, and I hope you guys enjoyed it, and until next time.